Welcome back, life science learners. Let's continue with our lesson. We are revising human impact on the environment today. Let's continue with looking at how we apply our understanding to the concepts around human impact on the environment. Earlier on, we looked at human impact on the atmosphere, and so we looked at the greenhouse effect, and we looked at the enhanced greenhouse effect in terms of the gases that have contributed to an increased average temperature on the Earth. Let's try and have some data around that and interpret what has happened in terms of the greenhouse gases and the effects that has had on the environment. So, here's a question, and we'll go through the question together, and then we will look at some of the questions based on this. An investigation to measure ozone concentration and the chlorine levels has been done in the Antarctica since 1950, and the results are shown in the graph on the next slide. So obviously, guys, concerns around the human impact on the environment hasn't just suddenly become an event in trying to monitor. There's been environmentalists that have been tracking this since early on, even before the 1950s. There was a lot of concern around the impact and the impact that humans were having on the environment. So we had naturalists, we had people that were in the field trying to capture data around what was the atmosphere and progressively looked at change. And so this concern hasn't been something that has suddenly been something that we have picked up in the last few decades. Okay, so let's look at the data that was collected. So guys, the graph shows you basically the information that was collected from the 1950s all the way till 1990. We have on the one set of the y-axis, we have the chlorine levels, and that's measured in pp, parts per volume, and that we'll refer to that as a unit. And then we have the ozone concentration, which is measured in an arbitrary unit there. And so we've got the ozone concentration here, and we've got the chlorine levels. And so the ozone concentration is indicated using the dashed lines, and the chlorine concentration is used indicating the solid line. And so guys, it's important that when you look at a graph, it's first to identify what is being illustrated, and then to try and see what the relationship is. It's important that you have a thorough understanding of, if you see a trend in that graph, that you understand and try and link the correlationship. So let's try and do that before we get into the questions. And so in this graph, you can clearly see that it's data that has been captured over a period of time, and we are looking at the comparison of the chlorine levels to the ozone levels. And so guys, if you do look at this, there's a general trend, and that trend shows you an increase in the chlorine concentration, and that is followed simultaneously with a decrease in the ozone concentration. So there is a relationship where you see one level increasing and then the other decreasing. And there's a scientific term that we use to describe that, and I'll get to that in a bit. Okay, so let's look at the questions based on this. So the first question, give a correct heading for the graph. Guys, it's important that when you label a graph or when you label a table, that you clearly state what the independent and dependent variables are. And in this case, we know that looking at this, we're obviously tracking levels over a period of time, and we're looking at chlorine as well as ozone levels. So let's try and put that into a decent heading that when someone reads that heading will have an indication of what the graph is actually depicting or illustrating. So let's try and put that together. As I mentioned, we're identifying that it's the independent variable is the level over a period of time, and the dependent variables are the chlorine levels as well as the ozone concentration. So how do we string that together into a decent heading? Now, I would use, so it'll be a graph showing, let me just write that down for you guys. So it'll be a graph showing now we're getting the dependent variables, so the chlorine levels, and that's important, and the ozone concentration, and that's the other dependent variable, which we need to recognize. And this is shown over a period of time. So it's graph showing the chlorine level and the ozone concentration from 1950 all the way till 1990. Now guys, for a 2-mark question, as I mentioned, you've got to have both the independent variable, which is the time period, as well as the dependent variable, which is the chlorine levels and the ozone concentration. So it's important that you do recognize that there are 2 dependent variables in this graph. Okay, let's move on to 1.2. What is the relationship between the levels of chlorine and the concentration of ozone? Now guys, as I mentioned earlier on, if we are looking at this relationship, I'm just going to change the color of my pen. I'm going to probably use, let's see if I can use yellow and how that looks. Okay, so here we're seeing the chlorine concentration increasing, and we can see that on the other graph, the ozone concentration decreasing. So what is this relationship when one variable increases and the other decreases? Yes, think about that. So it's an opposite relationship, and the better word to use that would be an inverse relationship. We can say that, what do I mean by that? It's inversely proportional. So it's inversely proportionate. And that essentially says that when one level increases, the other level decreases. And so this is important for us to be able to recognize as a concept when interpreting graphs. Okay, let's move on to the next question. Name the dependent variable or variables in the investigation. And now that we've given the graph a heading and I've helped you to identify the dependent variables, I think it would be very easy for you to be able to do that. Let's look at the mark allocation. Guys, it's a 2-mark question. So it's possible that the examiner is hinting that there probably are 2 facts or 2 points that need to be recognized. Yes, so we know that the dependent variable is only on the y-axis. And this is a little trick that I often help my learners to remember, the difference between the independent and dependent variable. So watch this space. I'm going to try and use a different color. So let's write down the letter I. I stands for independent variable. So where does that go? That goes on the x-axis. Let's write down the first letter of the dependent variable, D. Where does that go? Yes, it goes on the y-axis. So if you're ever confused about which of these axes represents the independent and dependent variable, write down the capital letter I, and that should help you to establish the x-axis. So it means that on the x-axis you have the independent variable, and then dependent variable on the y-axis. So that's a simple way that if you're ever confused and if you're doubting yourself, that's the best way to remember that. So if you do look at this, our dependent variables are the chlorine level as well as the ozone concentration. Well done to those of you that got that. Let's move on to the next question. 1.4. In which 10-year period was the ozone depletion the greatest? So guys, again, this graph illustrates the process of data collected over a period of time. The researchers are trying to establish during which 10-year period was the depletion the greatest. Now guys, it's pointing to the ozone, so we've got to make sure that we interpret the correct graph. So let's identify. So that's what we're looking at. Okay, the next part of the question is depletion. So depletion, again, another word for depletion would be a decrease. So when was the decrease the most? And that we need to identify in a 10-year period. So guys, remember that the gradient or the slope, the steeper the slope, the more significant the decrease. So essentially, what I'm going to point to is that if we were to compare these 2 lines, I would say that this is a more subtle decrease or a slower decrease, whereas this is a more drastic decrease. So we see a quick decrease, and that's essentially what's going to help us. So yes, we do see a general decrease, but there is a key that we need to identify in that there is a significant decrease in this slope, meaning it's much steeper. And that's between 1970 and 1980. Let's move on to the next question. In 1987, the Montreal Protocol was signed to lay down targets to reduce the use of CFCs by countries. And so this was a standard world agreement between several countries that they would undertake a necessary conscious approach to reducing their global emissions or the emissions of CFCs and other gases. And the idea was that if each country had reduced their production of CFCs and other greenhouse gases, this would collectively, as a world collective, reduce the impact that humans as one would have on the environment. However, well, let's see. Give two reasons why, despite a reduction in the use of CFCs, there was still a decline in the ozone layer. So guys, back in the day when in the 1970s and 80s, there was a serious concern around how large, how extensive the damage to the ozone layer was. And what was noticed is that the size of the ozone hole, there was holes in that were developing, and this started to increase. And there was more harsher radiation coming in from the sun. And so the idea behind that was if we reduce the global emissions of ozone, we would eventually be able to reduce the impact that it was having on the ozone layer. And so we're talking about CFCs being reduced. However, they realized that by reducing it, the impact was not immediate. And so the reason behind this was obviously several. One of the reasons was that the countries that had undertaken to do that had not fully committed, so they were still producing significant amounts of ozone. Another reason was that there was obviously the decay of the CFCs in the atmosphere was significantly slower than expected, meaning that there was large amounts of CFCs still in the environment. And so that to degrade and to lose its potency took much longer for the CFCs to actually denature until a point when the impact that it was having was effectively seen. So before we wrap the segment up, name one item that humans were using which contains CFCs. So guys, there are many different apparatus, refrigerant, coolers, or industries that use chlorofluorocarbons. So we know that it was used extensively in air conditioning, it was used in coolants in fridges, it was also used in the production of polystyrene or thermocol. And so all of those substances or industries that produced CFCs were significantly impacting on the environment back in the day. Okay. And finally, explain why the ozone layer is important for humans. And guys, as we unpack that, the ozone layer is an important layer that prevents the harmful radiation, the ultraviolet radiation that comes through the radiant energy from the sun. And it's able to filter that out and cut out the harsh UV radiation. And so we see that that plays an important role in reducing the UV radiation that humans are exposed to. So that's an important filter that we discuss.